Hello everyone, welcome to CampusX. In this video, we are going to see the newer methods of creating threads which are not only efficient but also memory effective. We are going to learn about thread pool executors. Let's discuss some of the problems of creating threads using threading.thread. The first one is thread creation time. When we apply thread.start, it takes a lot of time to create the thread in memory and start its execution. For comparison, here I have a chart comparing the context switch time with the thread creation time. By the way, context switch time is this, the thread creation time is this. It compares the context switch time with the thread creation time of Windows NT, 98 and Linux. What is context switch time? The CPU switches between processes. When the CPU jumps from one process to another, it's called the context switch, and the time taken to perform that jump is called the context switch time. Now compare it with the thread creation time. We see that a thread takes a long time to get created in comparison to the time taken by the CPU to switch between processes. Therefore, thread creation is a major overhead. The next problem we address is the number of threads. In our manual way of creating threads, we have no way of controlling the bounds on the number of threads running concurrently. The programmer has to manually create threads and has to make sure that he does not run so many threads at a particular time, which reduces the performance of the system to a significant extent. Here is a chart comparing the number of threads with the instruction per clock. We can see an exponential drop in the throughput of the system. Consider the example of a server. A server might have millions of requests to service. For each request, the server will create a separate thread, but creating a million threads could potentially lead to a server crash due to limited resource. Therefore, we want a bound on the number of threads that can be running at a particular point of time without having the programmer to manage all the threads manually. The last problem I would like to mention, which I could barely fit on this slide, is that threads once used, they cannot be reused again. That means when a thread completes a particular task that it was assigned to do, it just sits idle in memory and is cleared only when the process is cleared from the memory. We don't want dead threads to occupy memory. The solution to these problems are thread pools. The general idea behind a thread pool is to create a number of threads at process startup and place them into a pool where they sit and wait for work. These threads are called workers. Whenever a task is placed in the task queue of the pool awakens one of the workers which are sitting idle and uses that to complete the task. Servicing a task on a currently running worker is much faster than creating another thread. Another advantage is that when a worker finishes its task, it can go back to its idle state and it waits for more tasks. It does not become unusable like other threads and can be reused heavily. Another advantage of the system that you get a bound on the number of threads or the number of workers running concurrently on this system. This pool limits the number of threads that exist at any point, thereby allocating enough resources for all the workers to run smoothly. Now that we have seen the advantages of using a thread pool executor, let's see how we can implement this thing in Python. So here I have my usual setup that I did in the last video. So first of all, I am noting the start time, and then this function is something which has to be done on a separate thread. It prints going to sleep before it goes to sleep for 1 second, and then after waking up it prints woken up. At the end I am storing the end time, and at last I am printing how much time the main thread took to execute. So this is my usual setup. Now let's make a slight modification. I don't want to print something here. For demonstration purposes, I want to return this string. Now to use thread pool executors, you cannot import threading because it's not there. It's in the concurrent futures module. Concurrent.futures import thread pool executor. To use this thread pool executor class, you can either make an object or make a context manager. Context managers are easy. Using them are very easy because of a reason that I will tell you a little bit later. So we write with thread pool executor as executor. Now in this context manager, we want to submit a task to a worker. So for this we write executor dot submit. Inside the submit method we pass in the reference of the method that we want to run on a different thread. So in this case it's something, so we pass in something. Do not run the function, just pass in the reference. Now if this function takes arguments, you can pass the arguments here just by putting commas and like this. So here I have only one argument. I'll pass in the id as 0 and I'll store this task in a variable called task. So as soon as you execute this submit method, this thread pool executor will start it in a background worker, and when the task is completed, we can use a result method to fetch whatever is returned from this function. So we can just print it out. Now if I run this, let's see what happens. So it says going to sleep, and then it says woken up, and the main thread ended in 1 second. If you have multiple tasks, instead of using result one by one on all of them, we can use the as completed method. Let's see the benefits of the as completed method. First of all, let's just import them as completed from the concurrent futures module. Now let's create a list called task. I'll use list comprehension here. So first of all, I make 10 tasks, or I actually execute 10 submit functions. So we write executor.submit, and inside this I pass something with an id which will be I for I in range 10. So what I am doing here is I am creating 10 tasks and starting them. Now instead of using tasks.result, suppose task0.result and task1.result, we have this as completed method. So we can write for a throwaway variable in as completed, and we pass in the tasks, and then we write print underscore dot result. Now what this will do, that whenever a thread completes its execution, it's going to print the result irrespective of the order that we started it in. So let's run this. All the threads got kicked off at the same time, and they all woke up, but they were printed in the order they woke up. We can also pass in different sleep values to prove that as completed prints the result as they are completed. So let's just pass in the sleep time here. Sleep time, we will sleep for the sleep time, and inside this we can pass in, what should I do, 10 minus I. Okay, so it will be in the reverse order. So if I run this, all the threads got kicked off at the same time. Now 7 woke up, 6 woke up, 5, then 9, 8, 4. So they are printed as they complete. So this was the as completed method. Now there is also something called a map method. For example, let me just remove this sleep time. This was just for demonstration purposes, and we'll sleep for only 1 second. I'll remove everything. We have a map method. So for example, if you have IDs in a list like 0, 1, 2, 3, 4, 5, whatever, you can use the executor.map method to map these functions. So for example, what I'm doing here is executor.map something, comma, and I pass in the IDs list. So corresponding to every ID, every element in the list, it's going to start a worker, not start a worker, it's going to execute this something with that particular ID. And we store the result in a variable called results, because this map method is going to return us a list which is going to contain the results of all these something function with these IDs. And then we can just write for result in results print result. Now if I print it out, all the threads got kicked off at the same time and they woke up, and it was printed in the order they were started, because the map method gives back a list which contains the outputs of all the elements, all the something function that ran with these IDs. Now to prove that these statements are in order of these IDs, let's pass in our sleep time variable again. So here we pass in sleep time and sleep time. Now let us make a sleep times list. So let's say 5, 1, 3, 4, 6. I think there is one more, 7. And we pass in sleep times here. Now when we done this, all the threads got kicked off at the same time. Now we wait because the maximum sleep time here is 7, and now they printed all in order. So whenever an output of this something function comes with a combination of ID and sleep time, it just stores it in a list and we just display it. Okay, so the last thing that I want to show you is how can you change the number of bounds on the thread pool executor, that how many workers at maximum you want at a particular point of time. How can you change that? So here I am back with our old as completed method, and I have created a list. I have removed the sleep time and we just sleep for 1 second. I'm creating 10 tasks and putting it in a list, and as they are completed they will be printed. Now there is a parameter called max workers. This max worker defines how many maximum worker will be there in your thread pool. So for example, if I pass in 10, there will be 10 workers in your thread pool, and all the threads got kicked off at the same time because there are workers available and they woke up at the same time. Now if you change this max workers, let's say to 3, only 3 tasks get executed at a particular point of time, and they wake up at different whatever times they want. So you can see only 3 tasks get activated at a point of time. Now let's try with the worker 5, max workers 5. So we can see that 5 workers got kicked off at the same time. One of them woke up, and then another task got started in that worker, and you can see that only 5 workers are present at a particular point of time. So this max workers is the bound on your number of threads that will be created. Now why did we use a context manager? So here notice that we did not have to write anything about thread.join or something, any join function, because it is within the context manager. The context manager takes care of everything. It takes care of thread creation, placing this bound, waiting for another thread to complete. It does everything, and the main thread actually waits here until this thread pool executor has completed everything that it was supposed to do, and then it exits. So thank you for watching this video. In the next video we are going to start off with multiprocessing. How can you use the multiprocessing module in Python? So thank you for watching.